Okay, this is journal page 296, lesson 13.1. It says graph the linear equation, number 1. And we should start off with making an XY chart, XY table to see our list of values for our ordered pairs. So XY table. And X doesn't even show up in our equation. So it doesn't matter what I put in for X, be it 1 or 0 or -1, Y always just equals 4. Y equals 4, Y equals 4, Y equals 4. So our ordered pairs, and some of you probably remember from the lesson, this is just going to be a horizontal line. But let's write our ordered pairs that we have here. Remember, on any of these graphs, we're graphing their solutions because there's an infinite number of solutions. This is just 3 of them that we have here. And we'll use these 3 to plot some points on our graph over here. So here's the graph. And we have 1, 4. So 1, 4, 1, 2, 3, 4 right up there. 0, 4, so where X is 0, Y is 4. And -1, 4, so where X is -1, Y is -4. So really, we're just across that top of the graph. Put our arrowheads in there because this goes on forever. It's a line, and this is where Y equals 4. Y equals 4. Number 2 is the same type of problem. And we'll start with our equation, y equals -1/3 x. We'll make our table here, x, y, and our ordered pair. And now I'm going to be multiplying whatever I put in my value of x by -1/3. So that 1/3, I'm going to put values that are divisible by 3. So I'll use 3, 0, and -3. Now, if I put in 3 here, it'll be -1/3 times 3. Well, a positive times a negative gives me a negative. And 1/3 of 3 is 1. 0 times -1/3, of course, is 0. And -3 times -1/3, now I have 2 negatives, so I'm going to have a positive. And then 1/3 of 3 is 1. So my order pairs would be 3, -1, 0, 0, and -3, 1. So I take those points, and I'm going to graph them on our graph here. 3, -1, so where x is 1, 2, 3, our y is -1. 0, 0, so right through the origin, directly proportional if you remember that. And -3, 1, so -3, 1 right here. And we'll use a straight edge to do this. We don't just freehand it in there. And there is the graph, the line on our graph for number 2. Number 3 is a little different because it says solve for y. If you notice, our equation is not solved for y, like 1 and 2 were done for us. So let's start with solving for y. So for number 3, we have y plus 2x equals 3. Well, solving for y means getting y by itself. So I have to subtract 2x from each side, which now leaves y all by itself on this side, so yay, I'll be done. Remember, I can't add or subtract these. They're unlike terms. So I'm just going to have -2x and +3, or +3. Well, there's my equation now, and it's solved for y. So now I can put my x, y, and coordinates here. And let's try to find some easy numbers to put in here. Of course, I can always put 0 in for x. I'll make that my middle one. But if I put 0 in for x, then my x term becomes 0, and I just have plus 3. So 0 plus 3 is 3. If I put in 1 for x, then I'll have negative 2 times 1, which is negative 2. And negative 2 plus 3 is 1. And if I put in negative 1 for x, negative 2 times negative 1 will be positive 2. And 2 plus 3 is 5. So my ordered pairs would be 1, 1, 0, 3, negative 1, 5. Well, those are my 3 points I'm going to have to plot on here. But when I plot them on here, notice this only goes to 1, 2, 3, 4. And I need my y to go up to 5. So I'm just going to count by 2's on my y-axis here. So this will be a 2, 4, 6, 8. And of course, going down, same thing. So it would be negative 2, negative 4, negative 6, negative 8. Now, my x values were okay, so I don't have to do anything to get my x values on there. I'll leave that to go by 1s. So my first one, 1, 1. So where my x is 1, my y is 1. So I go up to just halfway because those are counting by 2's. 0, 3. So now my x is 0. My y is 3. Again, going up by 2's, so right in there. And negative 1, 5. So negative 1, 2, 4, 5 would be right there. One way to make sure our answers are reasonable is that this does form a line. So I draw my line in there and put my arrowheads on there. And number 4 is a lot like number 3 where we have to solve for y first. So for number 4, we have 2y minus 3x equals 1. We'll add 3x to both sides here, giving us 2y equals 3x plus 1. And then we have to divide by 2. Well, we divide by 2 over here. That's easy. That just gives us y. When we divide by 2 over here, we divide the whole thing by 2, which is the same as dividing each of these things by 2. And that gives us 3 halves x plus 1 half. So now we make our x, y table to get our ordered pairs here. There we go. And if we put in 1 for x, well, if we put in 1 here, 1 times 3 halves is just 3 halves, and 3 halves plus 1 half is 4 halves, which is the same as 2. So when x is 1, y is 2. If I put 0 in for x, then my x term becomes 0, and I just have plus 1 half, which is just 1 half. So when x is 0, y is 1 half. And if I put negative 1 in for x, negative 1 times 3 halves is just negative 3 halves. And negative 3 halves plus 1 half would be negative 2 halves, or negative 1. So when x is negative 1, y is negative 1. Well, now I have my 3 points that I can put on my table or my graph here. I have 1, 2. So when x is 1, y is 2. I have 0, 1 half. So when x is 0, y is 1 half. And I have negative 1, negative 1. When x is negative 1, y is negative 1. And I put a line through my 3 points. Well, on this last problem, it's already solved for us in terms of y. So the equation y equals 2x plus 4 represents the cost, y, in dollars of renting a movie after x days of late charges. So graph the equation. So first I'm going to make my x, y table. So for number 5, y equals 2x plus 4. There we are. And if I put in 0 for x, then this becomes 0 plus 4, so y equals 4. If I put 1 in for x, that would mean after 1 day of late charges, so I'll put 1 in there. And then 2 times 1 is 2, plus 4 is 6. So x is 1, y is 6. If I put in a 2 for x, 2 days of late charges, 2 times 2 is 4, plus 4 is 8. 2, 8. And then if I put in 3 days of late charges, 2 times 3 is 6, plus 4 is 10. 3, 10. Now notice I didn't put a negative number in for x this time like I normally do. Well, that doesn't make any sense to put in a negative number because that would be a negative number of days of late charges. It would be like the movie place owes you money because you have a negative number of late days. So we're supposed to graph this. So here are my points. Zero. Now, I have to get all the way to 10 for my y values, and obviously this does not go up to 10. My x values would be fine. 0, 1, 2, and 3 all fit here, but I have to get up to 10. So I'm going to count by, if I counted by 2s, 2, 4, 6, 8, I still don't get to 10. I'll count by 4s. 4, 8, 4, 8, 12, 16. All right, so for 0, 4 is my first point. My next one is 1, 6, so that'll be halfway between 4 and 8 there. 2, 8, and 3, 10, which will be halfway between 8 and 12. So right there. Notice I did not draw this so that it goes on forever in this direction, because remember, 0 is really the fewest you could go here on the x-axis because that's the number of days late, so we would not have a negative number there, but we do go off forever in this direction in case you had that whatever rented out for infinity. And it says use the graph to determine how much it costs after 3 days of late charges. And if we use the graph, so 0, 1, 2, 3 days would be right here. And we go up to see what the cost would be, and it was 10. So, and 3 days, it cost $10. So, $10 is the answer for part B.
See you! Ready for impact.